Hi, welcome to Ashok Kumar channel Physics. Today we are going to discuss a new topic and a very important topic for class 12, which is logic gates. Gate is nothing but for allowing and for not allowing, to open or to close. That is said with a gate. And logic means which type of the signal that you are giving for the gate to allow the persons or to allow anyone or anything. So and which type of the signal you are giving for the gate. So for should not allow. So these are said to be the logic. So by using the logic, gate has to be open. By using the logic, gate has to be closed. Logic means you are giving a type of signal you need to give to the gate in order to open or in order to close. Okay, so for example, if you are entering into the railway station, so you should have what you need to have in order to enter into the train. You need to have a reservation ticket. So and you should have a identity card. So if you have both identity card and a reservation ticket, so in the station the instrument is going to allow you. So that means if you have a reservation ticket, that is a signal for the instrument to allow you. So if you have a identity card, that is a signal for the instrument to allow you. So then gate is going to open and you can enter into the railway station. So if you have only reservation ticket and if you don't have any identity card, so then gate is not going to be open. So you should have both only when gate is going to be closed. So that is the type of signal to open or to close the gate. If you enter into the cinema hall, you should have a ticket. Without ticket, if you don't have ticket, then gate has to be closed. If you have, gate has to be open. If you don't have ticket, then gate has to be closed. So that is instruments will do work automatically. So if you have the ticket, then it is going to open. If you don't have, then it is said to be closed. That is said to be the logic. So by using that logic, gate is going to be open and gate is going to be closed. Sometimes you should have both. Sometimes either of one if you have, then gate is going to be open. So by and signals, which type of the signals you need to give. So there are two types of signals. A signal is nothing but a varying voltage or a current. That is said to be the signal. So we are giving a varying voltage and or varying current. So signal, by giving the signal to the gate, to the circuit, gate is nothing but it is a type of circuit. So and the circuit analyzes and opens the gate. So first of all, you need to give the signal to the gate. So signal is nothing but it is a varying voltage or current. And we are having two types of signals, that is two types of varying voltages. So one voltage is varying continuously, that means gradually it is increasing and gradually it is decreasing. So some type of signals are having just high and low value, high value, low value. So there is no gradual increase and there is no gradual increase. Either it has low or it has high. There is no gradual increase. So those are said to be analog and digital signals. Analog signals is nothing but, so if you take a graph of analog signals, if you take a V on y-axis and time on x-axis, voltage is varying with the time in both type of signals, in analog signals and digital signals. So in these two, voltage is going to vary continuously. How they are going to vary? So in the analog signals, voltage is varying like this. Voltage is going to vary continuously. So there is a low signal, intermittent signal. So that means there are so many voltages between high and low. This is said to be the high voltage and this is said to be the low voltage. And in between high and low, you are having so many intermittent voltages. Suppose if it is said to be the 5 volts and if it is said to be the 0 volts, between 5 and 0, you do have so many voltages between these high and low value. But a digital signal is not that type. A digital signal is either it is having a high value or a low value. Low value is nothing but a 0. So 0 is nothing but low in the digital circuits and 1 is said to be the high. That's it. So low means if it is having low, then it is said to be 0. If it is having high, there is no gradual increase. There is no in between voltages. Directly you are having high voltage. So in between high and low. This is said to be the low and it is said to be the high. There is no intermittent voltages. There is no in between voltages are there. So and again if there is high, there is high. If it is low again, directly it comes to the low position. So there is no intermittent voltages. So this is said to be the type of signal which is digital signals. These are said to be the digital signals. Digital signals are of types of blocks. These are said to be the block diagram, block graph. Okay. So one example of digital signals is nothing but the display of numbers in your calculators. Okay. Suppose your calculator is having a signal like this. 0 is nothing but like this. This is said to be the 0. So there is another circuit is there. So if it is 0, this signal is going to be off. That means low, that is 0. So in order to show 8, so all the circuits, all the LEDs, these are said to be the LEDs, all the LEDs must becomes high. That means all of should glow. In order to glow, they should have high voltage. If it is said to be the high, this is said to be the digital signals. So either high or low. Low means they are going to be off. High means they are going to be on. So best example of a digital display is nothing but the numbers on your calculator. Okay. So and we are having different types of logic gates. So first of all, you can write the what I meant by the logic gate. Logic gate is a type of circuit with the combination of transistors and diodes. So we will make the logic gates with the help of transistors and diodes. So it is a circuit combination of transistors and diodes. So by taking various input signals, various input digital signals, and it gives an output either 0 or 1. So you can write the definition of logic gates as it is a circuit. Logic gate is a circuit in order to open or close. So it is a circuit made up of transistors and diodes. It is a circuit works on digital signals. Works on digital signals, not analog signals. So this logic gate works only on digital signals, which has to give the clear that means what do we call so clear instruction you need to give. So only digital signals will give the clear instructions. It is a circuit works on digital signals. So taking so many input signals, and gives single output. So the input signals may be different. You can give so many types of input signals, but we need either it is said to be close or open. Gate final function is it has to be open or it has to be close. So that means either it should have a high value or it should have a low value. That is said to be the logic gate. So we are having basically three types of logic gates are there. Basic gates we will call them. So what are the basic logic gates? So the first basic logic gate is NOT gate. The first logic gate, which is said to be the NOT gate. Okay, so NOT gate means if you give the input signal high, NOT means low. If you give the input signals low, then NOT means high. The output is high. So that means whatever the input signal you are giving, that is making inverse of that signals. That is said to be the NOT gate. So for example, NOT gate diagram must be like this. This is just for our convenience. So in order to understand only. Suppose if you are having a bulb here. So this is said to be the source of voltage. So actually they are made with semiconductors and transistors. This is just for our idea only. So what is said to be the NOT gate, and what is said to be the NOT gate? How NOT gate will works? Okay. So current is moving from positive to negative. So current is going in this direction. So we set this bulb when you are having maximum current is allowed in this circuit. In this line, if maximum current is allowed, then bulb is going to be glow. So less than the maximum current, if there is a less than maximum current is passing through this circuit, then bulb is not going to glow. So that is how we set the bulb here. So, okay, as the current is flowing here, if it is open, if this switch is open, so this is said to be the signal we are giving. This is signal generally we will consider as A. So the signal here is 0. So open means there is no flow of current. As there is no flow of current is nothing but no flow of current in the A. That means signal is 0. So input signal is 0. So then bulb is going to be glow. What is the output we are having? So we are having high signal. If it is not having any signal, that means if the current passing through is 0. There is no current is passing through A. So that means the signal passed through A is 0. If the signal passing through A is 0, then what is the output? Output is bulb is going to be glow. Output you are having maximum current. Maximum means high current. High means output we are getting as high. So if it is no current, 0 current, then output is high. Output is output we are taking as Y. So generally input signals we are taking as A, output signal we are taking as high. And this output signal, what you are getting the output signal which is high. If there is no current, then you will get high current here. Okay. So that means it is inverse of this one. Suppose if you close this one, so then it is said to be the short. So always current is flowing through a short circuit. The current wants to flow in no resistance path. If it is having very high resistance, if this bulb is having very high resistance, then almost 95% of current is flown here. Then no current is flown in the output. So A is having high signal, then output is having no signal. So if A is having a high signal, high means if maximum current is flown through A, then bulb does not glow. Does not glow means output we are having 0. As it is not glowing, it is said to be off. Off is nothing but 0. As it is flowing, bulb is on. On is nothing but signal is high. High means 1. So that means if you give the input signal, it is making reverse. That means a bar, which is said to be the Boolean expressions. So the working on which expression this circuit is working, that is said to be the Boolean expressions. So NOT gate Boolean expression is Y is equals to A bar. This is the output. What we are getting the output. So which is based on the input, which is A bar. This is the NOT gate. Okay. And next another type of basic gate that is said to be the OR gate. Suppose if you take a circuit like this. So we are giving two input signals here. For NOT gate, there is only one input signal. There are no two input signals, either high signal or low signal. We are giving for NOT. So for NOT gate, the symbol is like this. For NOT gate, symbol is so here we are giving the input signal A and output signal we are getting as A bar. This is a NOT gate. Okay. And OR gate we are seeing. Suppose if there are two switches here, if current, these two switches are said to be two signals. As they are said to be open, there is no signal. There is no current is passing through them. That means there is no signal. Low signal means 0. So inputs are 0 if they are open. If they close, the inputs are given as 1. Suppose if you place a bulb here, I am taking different types of signals here. So signal A and signal B we are taking. So we are taking a different types of input signal. Always take the input signal of A as 0, 0, 1, 1. Always take in this manner. And the input signal of B is start with 0, 1, 0, 1. Always we will give the truth table. So these are said to be the truth tables. What is the function of this gate? What is the output? So whether you are going to get the high value or you are going to get the low value, the output of this gate is said to be the truth table. So what is the input you are giving, what is the output you are getting, that is said to be the truth table. So the truth table of this OR gate is, okay. So now if you see this circuit here, if A is having high signal means it has to be close. If A is close, then A is having high, actually A is low signal, A is 0. That means if A is having 0 signal, that means if it is open means there is no current, that is said to be the low signal. And B is also open, 0 means B is also said to be open. If both are open, then no current is passed through this bulb. So what is the bulb output? If bulb glows, that is the output, which is the high value. If bulb does not glow, the output is 0. So if both are open, 0, 0, if both are open, the current does not pass through the bulb, then bulb does not glow. That means there is no current comes here. So the output is 0. Output we are getting as 0 if both are open. If A is 0, that means A is open and B is closed. If B is closed, then maximum current is allowed through B. So the input signal is 1 here. Then output. So then current is having a path, it can move in this direction. It is open, but it can move in this direction. Then bulb is said to be glow. Output we are getting as 1. If A is closed, if A is said to be closed and B is said to be open. So 1, 0. A is 1, B is 0. So then again it is having a closed path. Then B bulb is going to be set glow. That is you are going to get 1. If both are closed, A is 1, B is 1. Both are said to be closed. Then current is going to divide, but again the divided current will club here and you will get the high signal towards the bulb. So that means you are going to get high signal. So if bulb glow, that is said to be high. If bulb is not glowing, that is said to be low. So you cannot do this 1 plus 1 is 2. So we don't have 2, 3, 4. So if it is glowing, it is said to be 1. If it is not glowing, it is said to be 0. How do you get this one? The Boolean expression of OR gate. So what is the Boolean expression of OR gate? Which is y is equals to, if you see here, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. Actually we don't write 2, 1. So that means high signal. So this is the Boolean expression of OR gate. Y is equals to A plus B. That is said to be the OR gate. OR gate Boolean expression. How do you get the output in the OR gate? So with the inputs, if you do the addition, then you will get the OR gate output. So this is the Boolean expression for OR gate. So the symbol of OR gate, the symbol of OR gate is you are having a concave curve and this one. Here we are giving two input signal, the signal A and signal B. So these are said to be the inputs. So A and B, and the output is said to be according to Boolean expression. According to which Boolean expression it is working? It is working on the Boolean expression of y is equals to A plus B. That is said to be the OR gate. Okay. And another basic gate here is AND gate. So we have seen the NOT gate, we have seen the OR gate. In the NOT gate, only one input signal we are going to give. In the OR gate and the AND gate, we are going to give two input signals. And next, AND gate. What is the circuit of AND gate? To know. And what is the truth table of AND gate? And what is the symbol of AND gate? So next is AND gate. So suppose if you are having a circuit like this in the series, so both the signals are in the series connection. This is the signal A and this is the signal B, and they are connected to a battery, and here is a bulb. Okay. So now the AND gate, if you see, so here we are giving the two input signals which is A and B. And what is the output we are going to get? According to which Boolean expression we are going to get the output? So we need to get this Boolean expression. First, how do you take the signals? A is 0, 0, always take in this manner. And B is 0, 1, 0, 1. Okay. And suppose if you see here, if A is 0, that means A is open. And B is also open. Any current will flow in this circuit? No current is going to be flow. Then output is 0. If it is not glowing, there is no current in the bulb. That means output is 0. And next, A is open, B is closed. A is open, B is closed. If you close the B, B1 means B closed. If you close the B, any current will flow through the circuit? No, because here it is open. So no current will flow. Again you will get no current flows through the bulb. That is the output. That is 0. Suppose if B is open and A is closed, that is 1, 0. 1 means A is closed, B is open. A is closed means and B is open, then any current will flow. Here also there is no current will flow. That output in the bulb is 0. And if A is closed, B is also said to be closed. 1, 1. 1 means close. So if both are closing, then you will get maximum current will flow through the output of the bulb. So how do you get this one? What is the Boolean expression for this one? Can you see 0 plus 0 is 0? Okay. 0 plus 1 is 1. But here we are getting 0. How do you get this one? By multiplication. 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 0. That is the Boolean expression here. The Boolean expression for AND gate. Directly you can take. So AND gate Boolean expression is y is equals to A into B. And the symbol of AND gate is, here we are giving two input signals and there is a D at last. So based on, so that's why it is in the shape of D. And output expression, which is the Boolean expression, and which Boolean expression it is working, AND gate is A into B. And here the input signals we are giving A and B. So these are the three basic gates. NOT gate. For the NOT gate, how many signals you are going to give? Only one input signal. Okay. And OR gate is the addition. And AND gate is the multiplication. So if you remember these Boolean expressions, then you can do any type of truth table. So any type of the logic gate. And the next, combination of gates. Combination of the basic gates. Basic gates are NOT, OR and AND. Okay. So combination of these gates are nothing but, so we can take the truth table. So this is the circuit for explanation. Actually this is not a real circuit. So actually circuits are made up of the diodes and transistors. So these circuits only for our explanation. And the symbol of these gates, logic gates, AND gate, OR gate. You can take a screenshot, and next we are going to get the complex gate, that means combination gates. first combination gate is NOR. NOR gate. What do you mean by the NOR gate? NOR means, N means not. Not after OR. NOR means not after OR. That is said to be the NOR gate. So after OR gate, you need to take reverse signal. So that means NOT gate. After OR gate, NOT gate. That means the first gate is OR gate. After OR gate, you take NOT. First OR gate, and next after OR, NOT gate. This is said to be the NOT gate. So here the input signals, if you give A and B, these two are the input signals. And this is the intermittent signals. So this is the final output. Here is the final output. So we are taking this one as Y. And this is the intermittent signals, intermediate signals, between signals. So what is this output? This output, if you take this one as Y dash, this output is, this symbol is R. So the output of OR gate is on which expression it works, which is A plus B. This is the intermediate signal. And the final output is after R, this is R. For this one, you need to take inverse signals. For A plus B, OR gate has to be reverse. This is the OR gate, has to be reverse. Reverse means A plus B whole bar, not. This is R, which is A plus B. For A plus B, you have to do the reverse. A plus B, we are doing the reverse, which is A plus B bar. Actually, this is the vector, just A plus B bar. Okay. And the combination signal. So that means combinedly, we can write this symbol as just we will take here. These two are looking like same, and we are combining this. This is the final NOR gate. This is equivalent to this one. This final symbol is equivalent to this one. So which is, this is the input signal A and B. First we are doing the OR, and next this is said to be NOT. OR and NOT, which is the NOR gate. So finally we will get Y is equals to A plus B bar, inverse of Y. Okay. So and the truth table. What is the truth table here? If you give the input signals are A and B. So A is the input signal and B is another input signal, and there is an intermittent signals. Intermittent signal is Y dash, where Y dash is equals to A plus B, and final signal here is A plus B whole bar. So final signal here is Y, which is A plus B whole bar. Always I am getting the vector. Y is equals to A plus B whole bar. So how do you take the signals? Always there is a format which is 0, 0, 1, 1. This is the format of signals. And B you need to take as 0, 1, 0, 1. These are the input format always you need to take in order to get the truth table. And intermittent signal, Y dash is equals to A plus B. Here this is A and this is B. A plus B. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is, don't say 2, this is 1. Only you are having high and low. High is the 1, low is the 0. And final output signal. So NOT gate output signal, Y is equals to A plus B inverse. A plus B inverse. A plus B values are, A plus B output is 0, 1, 0, 0, 1, 1, 1. And inverse of these values is, for 0, inverse is 1. For 1, inverse is 0. For 1, inverse is 0. For 1, inverse is 0. So invert of addition, 0 is the additional inversion. Okay, so this is the NOR gate output. So the NOR gate works on the Boolean expression. And which Boolean expression NOR gate works? A plus B bar. So that is the NOR gate Boolean expression, and that is the truth table, and this is the symbol. Okay, and next we are going to see the another combination gate, which is the NAND gate. You can take the snapshot for this one. Okay, next NAND gate, which is the very important one. which is said to be the universal gate. NAND gate. So NAND gate means NOT gate after AND gate. Not after AND. That is said to be the NAND gate. Okay. First you need to take AND, next NOT. AND gate is like this. You do have the AND gate. This is the AND gate. After AND gate, NOT gate. For NOT gate, only one input has to give. NOT gate always having only one input. This is said to be the NAND gate. NOT after AND. So the input signals are A and B, which is this is said to be the intermittent signals. Y is equals to AND gate. AND gate Boolean expression is A into B. And final output you are going to get, which is the NAND gate Boolean expression, which is NOT and NOT. So AND is A into B, and this is invert NOT. Okay. And final symbol you can write, combinedly you can write the symbol as, this is the AND. If you take a small bubble is there, then it is said to be the NAND gate. So here is the signals A and B. The final Boolean expression Y is equals to this is said to be A into B, and is A into B, and this small bubble is bar, inverted signal. Okay. And the truth table. Truth table is, so the input signals are same, which is A and B, and the Boolean expressions, the intermittent Boolean expression is A into B. And the final Boolean expression, final output is A into B whole bar. That is the final output. And how do you get this truth table? So first A into B, that is 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. That is the AND gate. And NAND gate is reverse of AND gate. So 0 reverse is 1. 0 reverse is 1. For 0 reverse is 1. For 1 reverse is 0. Okay. So this is said to be the NAND gate. Okay. And this is said to be the universal gate also. NAND gate is said to be the universal gate. Very important one for your class 12th. Why the NAND gate is said to be the universal gate? Because by using the NAND gate, you can make basic gates. By using the NAND gate, you can make the NOT gate. By using the NAND gates, you can make the OR gate. By using the NAND gate, you can make OR gate, AND gate, and NOT gates. How do you make a NOT gate from the NAND gate? Okay, which is said to be the universal gate. So you can take a screenshot for this one, which is the symbol of NAND gate and Boolean expressions and the final truth table of NAND gate. Okay. And next, how do you make a NAND gate as a universal gate? So that means how can you make a NOT gate from the NAND gate? How can you make an OR gate from the NAND gate? How can you make AND gate from the NAND gate? Okay. For that one, if you take a NAND gate, so this is said to be the NAND gate. NOT gate, we are making this one as a NOT gate. For NOT gate, how many signals we have to give? Only one signal. NOT gate requires only one signal. We are clubbing these two. This is A and this is B. But we are clubbing them and making as single input signal. Okay. Suppose these are A dash, B dash. Here the input signal I am giving as A. What is the final output signal? So NAND gate Boolean expression is, just now we said, AND is NOT. AND is A into B. For this AND you need to make the reverse, A into B bar. Okay. So is it becomes a NOT gates? Yes. If you take the truth table, if you see the truth table, so A, if you give A either 0 or 1, that's it only. So there is only one input. If there is only one input, either I can give the 0 or I can give 1. Only two inputs are there, either 0 or 1. Okay. So what happens to A dash? So if A is 0, A dash means, so that means not bar, the A signal is coming here. Same the A signal, which is A dash is 0 and this is 1 only. And B dash, the same signal comes here, which is B dash is also 0 and 1. And this expression, if you see the expression, y is equals to A into B whole bar. What is the output? If the output is the same as NOT gate, then it becomes as NOT gate. So A into B. So this is not A into B, A dash into B dash whole bar. A dash B dash whole bar. So A dash B dash whole bar. So A dash is 0, B dash is 0. 0 into 0, 0. But it is inverse of AB, A into B. So 0 into 0, 0. But the inverse is 1. And next, A dash into B dash. A dash into B dash is 1 into 1 is 1. But reverse of 1, this is bar. Bar means reverse. Reverse is 0. So that means this is the input signal, main input signal we are giving. And what is the output signal we are getting? So the input signal is 0. What is the output signal you are getting? 1. If the input signal is 1, what is the output signal you are getting? 0, which is the NOT gate, which is the reverse of input signal. Input signal is 0, reverse is 1. Input signal is 1, reverse is 0. It becomes as a NOT gate. And next, how can you make this NAND gate as a OR gate? Okay. For that one, okay, suppose the input signal, we are giving the two input signals, which is A and B. So this is said to be the, what is this? This is the NAND gate. NAND gate. NAND gate expression is the Boolean expression of NAND gate. If you take this was as Y dash, the Boolean expression of NAND gate is AND is not, AND is A into B and NOT is bar, A into B bar. So this signal, A into B bar signal, is coming towards again a NOT gate. So what is this gate? This is said to be the NOT gate, which is same as this one. If you see this one, same as NOT gate. So this totally we can make this one as a NOT gate. Okay. If you write the truth table, so truth table of this circuit. First, so there are two signals, A and B. The two input signals, A and B. How do you take the input signals? 0, 0, 1, 1. These two are, that is the formation of input signal. So 0, 1, 0, 1. And intermittent signal is Y dash is equals to A into B whole bar. That is the intermittent signal. So A dash into A into B whole bar. A into B is 0 into 0, 0. But it is bar, inverse, which is 1. 0 into 1 is 0 and inverse is, 0 into 0, 0. Okay. 0 into 1 is 0 and inverse is 1. 1 into 0, 0 and inverse is 1. 1 into 1, 1. But inverse is 0. Okay. So and this signal is coming towards the NOT gate. This is the NOT gate. So see the word NOT gate. NOT gate means reverse. So this is the NOT gate. NOT gate makes this signal A into B bar signal makes the reverse. So and this is the NOT gate. NOT gate, what is the final expression you are getting? NOT gate is Y dash. This is Y dash bar. This input signal becomes reverse, Y dash bar. So the output is Y dash bar. That means A into B bar, again bar. So Y dash bar. So that means if it is 1, then it is 0. If it is 1, then it is 0. So you need to make the reverse for this one. If it is 1, if it is 0, if it is 0, and if it is 1. So we are making the reverse for these signals because this is a NOT gate. So already we have seen this is a NOT gate. NOT gate means the signal becomes reverse. Y dash becomes inverse. Okay. So if you see this one, the final output signal, which is 0, 0, 0, 1. So the truth table final output to table 0001 for which gate it is having AND gate. So if you see 0 into 0 is 0, 0 into 1 is 0, 1 into 0 0, 1 into 1 1, which is said to be the AND gate. So it becomes as an AND gate. NAND gate becomes as an AND gate. Here we are using only NAND gates. So no other gates are here. By using the NAND gates, we make the NOT gate. By using the NAND gates, we make the AND gate. And again, by using the NAND gates, we can make OR gate. Okay. So how do you make the OR gate? So I can rub this one. You can take a snapshot for this one. So this becomes the AND gate. How can you make NAND gates as AND gate? How can you make NAND gate as a NOT gate? So this total becomes as a NOT gate and this total becomes as a AND gate. And next we are making NAND gates as OR gate. Another basic gate which is the OR gate. Okay, for that one, this is a NAND gate. Only by using NAND gates, we need to make basic gates. Okay. So here the input signal is A and this signal I am taking as B. So what is this one? Already we have seen this one is a NOT gate. This is a NOT gate. This is also NOT gate. Then you will get this one is A bar and this one is B bar. So why I am getting always a vector bar? So A bar and B bar. So that means the signals which are coming here as A bar and B bar. So and the final output signal. So the final output signal, this is a NAND gate. NAND gate means multiplication of these, which is A bar. Again I am getting the vector A bar, B bar, whole bar. Again there is a inverse. A bar dot B bar whole bar. That is set to the final Boolean expression. If you write the truth table, it has to be OR gate. So the truth table of this, at first the signal is A and another signal is B. So signals you need to take as 0, 0, 1, 1 and it is 0, 1, 0, 1. Always you need to take the signals like only in order to explain. And next A bar and B bar. A bar is inverse of A bar. A bar is 0, here is 1. A bar is 0, A is 0, then A bar is 1. A is 1, then A bar is 0. A is 1, A bar is 0. Okay. And next B bar. What is meant by B bar? B bar is inverse of B. So B is 0, B bar is 1. B is 1, B bar is 0. B is 0, B bar is 1. B is 1, B bar is 0. And next, is it correct? 0, 1, 1, 0, 0, 1, 1, 0. Okay. And final expression, final Boolean expression here is y is equals to A bar dot B bar. Again I am getting the vector. A bar, B bar, whole bar. Okay. So A bar dot B bar. First to do A bar dot B bar is 1 into 1 is 1. And the reverse of that one is 0. 1 into 1 is 1. But inverse is 0. 1 into 0 is 0. But again you need to get the inverse. A bar dot B bar you need to do. So as you are doing A bar dot B bar, for that output you need to make the reverse. So 1 into 0 is 0 and inverse is 1. 0 into 1 is 0 and inverse is 1. 0 into 0 is 0 and inverse is 1. So if you see this truth table, these are the input signals 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, you are getting 1. So that means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. These are the input signal, that is the output signal. So that resembles the same as OR gate. Y is equal to A plus B. So this is the OR gate. We make the NAND gate. So the combination of NAND gate becomes OR gate. So NAND gate is used to make the basic gates. That's why it is said to be the universal gate. Okay. So I hope you have understood this. And in the next class we are going to see the complex gates. Okay, so this is the basic information about the gates, and how to apply them for NEET questions or G mains questions. Okay, we will get the complex circuit. There is no complexity. If you follow my explanation, then it is very easy. Okay, thank you for the today's class. Bye.